everybody, welcome back. We're going to continue 4.6. This is the day you're not going to like. This is maybe one of the days that is your most unfavorite. Your most dislike, unfavorite, is that even a word? Your most disliked days, because we're graphing today a lot. So let's start off. We want to continue doing some stuff with end behavior. We got stuff with radicals in it. So this is just easiest to just jump into some examples. We're going to find the limit as x goes to plus infinity or negative infinity for f of x equals 6x plus 5 over the square root of 9x squared plus 2. And I'm putting down the definition of the absolute value of x. Again, this is really important because we're going to use all parts of this kind of thing. So it equals the absolute value of x is the square root of x squared, or it's x if x is greater than or equal to 0, and negative x if x is less than 0. Now, if we look at the bottom, the square root of 9x squared plus 2, for large x, that 2 becomes unimportant. Like if I plug in x is like 1,000 here, if I stick in like 1,000, this is like 9 million plus 2. The square root of 9 million plus 2 is like the same as the square root of 9 million. So we can drop the 2, and we'll see that, like, using these rules up above, square root of 9x squared is 3 times the absolute value of x. So that's for large x. So instead of multiplying by 1 over x, what we're going to do is we're going to multiply by 1 over the absolute value of x. And we're going to use the appropriate version. Use appropriate version for the side you're on. As you'll see in a second. This will make more sense when we look at it in a second. Appropriate has another R in it right there. Let's see. Appropriate. There we go. So the bottom we're multiplying both by 1 over absolute value of x. The top doesn't have any radicals in it, so we're just going to use the piecewise version. And for x going to positive infinity, we're going to positive infinity. We're on this side here. We're using that. Okay. So we're going to use 1 over x. That's right there. And when we do the bottom, that's where we have the radical. That's where we're going to use 1 over square root of x squared. We're going to use this version over here. So if I do that, I rewrote it, replacing the 1 over absolute value of x. And as I distributed in this, and I showed it fully distributed before I did any math here. So you distribute it there, and we get this. And you distribute this onto each one on the inside, and it puts it on the bottom on the inside. And since it's already in the radical, nothing's being changed. It's good to go. So when we look at it, this is like, once we clean up, this is the version we get. So as we go to infinity, that value goes to infinity, which means this goes to 0. Okay? So that goes to anything with the denominator goes to 0, like we did yesterday. So we're left with 6 over the square root of 9. That's 6 over 3, which equals 2. So the limit when we get large is 2, which means we have a horizontal asymptote at y equals 2. Okay? Does it change when we do x equals negative infinity? What do you think? Well, let's go back up and look at our absolute value function. When x is negative, going towards negative infinity, we are going down. We are going down this branch right here, which means where we did 1 over x before, we're going to do 1 over negative x this time. So it does change it. So same setup, bottom still looks like this. Now on top, we're doing the negative 1 over x. I still distribute like I did. But now this on top, notice this is now a negative 6 right here. It's not positive 6 anymore. So we have a different final limit of -2. So there's a horizontal limit or a horizontal asymptote of y equals -2 going that direction. And if we actually, when we plot this in Desmos, we're going to do this kind of stuff by hand later on. When we plot this in Desmos, we get like a graph like this. So there's my asymptote at 2, there's my asymptote at -2. And we can see that as it's approaching it, it's going towards this value. That we're just talking about end behavior right now. Okay. So why don't you guys try doing one? Find the limit as x goes to infinity and x goes to -infinity of f of x equals the square root of 3x squared plus 7 over x plus 5. I'll assume you did that. I'll scroll up. So we're multiplying by 1 over absolute value of x again. The top here gets the radical version, and the bottom gets just the regular x. And on the, like I did them both at the same time, when we're going to -infinity, notice it's -1 over x here, but it's +1 over x there. Okay? But when we distribute, we end up getting square root of 3 on the left, and we get negative square root of 3 on the right. It's kind of interesting. If we take a look at the graph, we get this. Okay? So we do see that. Notice it does go towards it as we're going towards, it goes towards the asymptotes as we're going towards them. But you can cross a horizontal asymptote, but you can't cross a vertical asymptote. Okay? And that'll be the end of this video. Next one, we're going to look at end behavior for transcendental functions.